Hello everyone. In my PhD project, I'm investigating the role of artificial intelligence in decision-making for extubation of mechanically ventilated patients. I'm Péter Bakos, an anesthesiologist and intensive care physician working in West Prim at the Department of Anesthesiology and Intensive Care. My vision is healthcare professionals at the bedside relying on data instead of customs and traditions, while my mission is to provide evidence on data-driven decision-making in critical care. In order to achieve my vision and mission, I set specific goals. First, I will investigate the accuracy of machine learning models in predicting extubation success. And then, based on the results of the first study, in a second step, we are planning to develop and validate a machine learning model to predict extubation success in mechanically ventilated patients. So starting with the first project and its background, the most important problem related to the topic is that almost half of our intensive care patients are mechanically ventilated. There are existing local and national protocols on extubation, but despite these protocols, reintubation rate remains quite high, between 10 and 20%. Also, the practice on extubation varies widely among centers and physicians, leading to inconsistencies. So what do we know so far? We know that even failed or delayed extubation may cause complications and affect outcomes, such as ventilator-free days, length of stay in ICU, or increased mortality. Also, it has been already shown that machine learning can predict outcomes such as mortality or renal failure. So what is really missing is consistent guidelines on extubation and evidence certifying the predictive accuracy of machine learning on extubation success. So what we can do for that is investigating the performance of machine learning models. In this study, our critical question is whether machine learning models are superior to standard medical therapy in predicting extubation success in mechanically ventilated patients. To answer this question, we would use the PIRD framework, where population is mechanically ventilated patients undergoing extubation. Index test 1 is machine learning models. Index test 2 is standard medical therapy. Reference is extubation success. And D is prediction accuracy. So the hypothesis is that machine learning model is superior to standard medical therapy in predicting extubation success. The clinical and research implication of our study would be the use of machine learning models as part of standard of care. Having these kind of tools in clinical practice could first improve our patients' outcomes, second, decrease the burden of healthcare professionals, and third, enhance cost effectiveness. We conducted a systematic search in 3 different databases. Our search key consists of 2 domains. Domain 1 refers to the population of the study, and domain 2 refers to the machine learning models and predictive algorithms. We had more than 13,000 results, and after duplicate removal, more than 9,000 results remained. We are currently at the end of the title and abstract selection, moving forward to full text selection. So based on the results and findings of our first study, we are planning to develop and validate a machine learning model to predict extubation success in a second step. Coming back to the background of the first study, we know that despite the high number of mechanically ventilated ICU patients, the practice on extubation is still inconsistent. Also, we need accurate tools supporting decision-making. For that reason, we are planning to develop a clinically relevant and applicable machine learning model. We performed a preliminary search in the literature to find accessible ICU datasets. In a systematic review, 4 open-source, large, well-structured datasets were identified that we are planning to use in this study. Building a machine learning model consists of several steps. First, we need to start with idea conceptualization, where we need to define features or predictors and output of the model, which is extubation success in our case. In a second step, we need to collect the data. Actually, this step could take even years or decades. For that reason, as I showed you on the previous slide, we are planning to use well-structured, already available large ICU datasets. The third step is tool identification, where we need to define the programming language and the machine learning framework which we are planning to use. At this stage, let's jump to the image to the figure on the right in order to understand the term supervised learning in machine learning. We are using this method because supervised learning is a type of algorithm that applies features, predefined predictors, and outputs. With the help of a labeled data set, our model is trained in order to make predictions and decisions based on new unseen data set. The next step is data cleaning, where we need to find inconsistencies, missing values, and outliers in the data. And then we need to build our model and evaluate its performance. At this stage, we need to separate our data to training and validation set. Once our model is trained, we need to measure its accuracy. What we have until this stage is a programming code. So in the next step, we need a deployment where we implement our model in a real-world environment, in an application or online platform. And of course, once we have our model, we need to share it with users, with clinicians, and we need to rely on their feedback in order to improve our model and start the process again. So our critical question is whether machine learning model is superior to standard medical therapy in predicting extubation success in mechanically ventilated patients. We would use the same diagnostic framework as for the first study, and our hypothesis is that machine learning model is superior to standard medical therapy in predicting extubation success in mechanically ventilated patients. The clinical and research implication of this study would be the validation in a prospective study and application in clinical practice. So in summary, in the first year of my PhD training, I'm planning to investigate the accuracy of already existing machine learning models, and based on the results of the first study, we are planning in the second step to develop and validate a machine learning model to predict extubation success. And for the question, when to extubate a patient, the answer, my friend, is blowing in the wind. It's in the data, but we need to find it. Thank you very much for your attention.
A very quick introductory question for you. You mentioned that 10 to 20% was the rate of reintubation. What are the most common causes for reintubation? What happens to these patients?
Actually, it depends on the population or comorbidities or the baseline illness, why the patient was intubated. In some cases, it can be muscle weakness. In other cases, for example, traumatic brain injury patients, it can be the lack of consciousness, or it can be any kind of harm to the lung that is not solved yet. So it depends on the feature and on the population of the current ICU which we are talking about.
I'm not really familiar with the field, but you said you're going to measure success. How exactly will you measure the success? Is it kind of like
we are not measuring the success, but we are measuring the accuracy of the model in prediction of success. Okay. Because these are already available data sets, so what we are analyzing in this data is already happened. Okay. So for that reason, we need to see our models, which are trained based on these data sets, are how accurate in predicting extubation success.
Okay. I just wanted to ask, because obviously I'm not a doctor, like what types of parameters do you look at when you're making the decision that's blowing in the wind? Yes. So like what are the things that guide you still?
Yeah, actually in the literature they are looking at many parameters, and that's the reason why I really want to investigate this, because a human practitioner cannot integrate all these parameters in clinical practice. So we are looking at hemodynamic variables. We are also looking at the setting of the respirator or the ventilator. We are looking at laboratory parameters, the consciousness of the patient, blood gas values, comorbidities, and I could say many others. So for that reason, the problem is that there is no existing guideline how to extubate a patient. But in the ICU, we have plenty of data, which unfortunately sometimes goes to the garbage and we don't use it. For that reason, it would be very nice to have a model which can predict the success of the extubation, and that could help the decision-making of practitioners.
let's say your model works fantastic and machine learning is superior to us.
Yes.
What will happen with my job then?
You can stay at home. No, actually, I think these models can support or help our work. So, for example, if you have a complicated patient and your model says that it's 85% that the extubation will fail, then maybe you will not go into it immediately, but do it with a delay or try to improve some parameters because you assume that it will be a fail.
Machine learning is actually not new. And 10 years ago, companies like Varian Medical Systems and Electa and Radiation Oncology were already working with very big data sets to optimize treatment patterns, well beyond what a human being could do. The question is, what's really new here? Are the algorithms more powerful? Are the data sets better? What is really different?
What is new in this field is that I think in the ICU we have the largest data that is generated, but we don't use it. Actually, we don't even collect it in a right manner, and we don't use it, and that's a problem. And without using this large big data, we cannot benefit of it. So for that reason, yes, you are right. The models are existing. They were here 10 years ago too, but we cannot train them because we don't have collected data. And for that reason, now they are starting to work on these available, well-structured, open-source data sets. And of course, we should make, even in Hungary, a registry or to collect all the ICU data in order to be able to do predictions like this.